Imagine having an assistant that could do, well, anything you ask. Seriously, anything.
Hmm.
From planning a really complex international office move for, say, dozens of employees, finding the office, sorting out accommodation,
Right.
to maybe just redecorating your living room, finding the perfect furniture, and all without you having to lift a finger or, even stay glued to your computer.
It sounds like the dream, doesn't it? An assistant that really gets things done.
Exactly. Well, today we're diving deep into a technology that's actually making this sort of thing, well, real. It's
Okay.
called agentic AI.
And specifically, we're looking at a company called Manus AI.
That's our mission today on the deep dive. We're going to unpack Manus AI. What is it? How's it built? And why does it feel like such a big step forward in making AI genuinely useful, out there in the real world?
Yeah, and our guide for this is a really captivating talk by Tao, who also goes by Hake. He's the co-founder and chief product officer of Manus AI.
And he shared the whole story, the origins, the philosophy behind it, and some, frankly, mind-blowing examples of what it can do.
Absolutely. And to really get Manus, it helps to know a bit about Tao himself. He's been coding for, get this, 28 years. Started when he was just 9.
Wow, 9 years old.
Yeah. But interestingly, he's actually quite new to the AI scene itself, only about 2 years in the industry.
Huh.
Despite that, he has this huge ambition of build a product that can influence a single user 24 hours a day.
24 hours, that's a lot.
It is. He thinks Manus AI can actually hit that target by the end of this year, 2025. And that means going way beyond the current limit, which he mentioned is about 2 hours of GPU use per user per day.
So they're talking about continuous, dedicated AI power for everyone.
That seems to be the goal, really pushing how much AI works for you constantly.
And the name, Manus,
Yeah,
that's significant too, right? It really ties into their whole philosophy,
it does. It comes from the MIT motto, mens et manus.
which is Latin for.
Mind and hand. And that right there is the core problem Manus AI is trying to solve.
Okay, explain that. Mind and hand.
So the basic idea is this. These big cutting-edge AI models, the frontier models, they have incredibly smart brains, the mind part,
Well,
but they often lack the hands, the ability to actually execute tasks effectively in the real world. They can think brilliantly, but they struggle to do.
right, like they're trapped in the computer.
Exactly. And Tao shared this great personal story. He said back in 1996 in China, he was this top coder at 9 years old.
Yeah, you mentioned.
But he couldn't actually get his code right because he didn't have a real computer to test it on. He could write it perfectly on paper, but debugging, running it, impossible.
Oh, okay. So he sees current AI like that. Smart on paper, but needs the machine, needs the hands.
Precisely. He feels like AI today often just gets a pen and paper, metaphorically speaking. It doesn't have the means to really interact and execute.
And that's where Manus comes in. They're not building the mind.
No, they're very clear on that. They don't train models, they don't fine-tune models. Their entire focus is purely on building the hands for these existing powerful AI minds.
So they provide the connection, the bridge between the thinking and the doing.
That's a perfect way to put it. Enabling these AIs to perform actual, tangible actions.
Okay, so building hands for AI.
Hmm.
What does that actually look like in practice? How does Manus let these models, get their hands dirty in the real world? Tao gave some examples, right?
He did, and they're really impressive. One of the most compelling ones was Manus using its own system for a real internal need.
Oh, eating their own dog food, so to speak.
Exactly. They needed to find an office and sort out housing in Tokyo for 40 employees they were relocating. A huge task.
40 people to Tokyo. Wow, okay. That's complex. What was the prompt they gave it?
Something direct, like, we have 40 people relocating to Tokyo, find an office that fits 40 people, and also solve their accommodation problem.
Simple request, incredibly complex task. So what did Manus do?
It just went to work. It planned the steps, it executed them, it browsed and researched countless websites. We're talking digging through massive amounts of online information.
Okay. And the result. How long did that take?
Yeah. This is the kicker. 24 minutes.
24 minutes. For all of that.
Yep. In 24 minutes, it delivered a fully interactive website. Title: Tokyo Office Accommodation Recommendations.
No way. What was on it?
It had an interactive map with 10 options pinpointed, blue markers for potential offices, green for nearby housing.
Wow.
It even gave specific examples like Shibuya Scramble Square, noting it was probably, quote, too fancy for a startup.
Ah,
and then suggested a more suitable office 200 meters away, including pricing and reasons why it was a good fit, plus accommodation options with distances to that office and a big summary table comparing everything.
Okay, that's seriously impressive. You
Yeah.
think about asking a person, even a great assistant, to do that. 24 minutes, not likely.
It really makes you pause, right? The sheer speed and comprehensiveness.
It does. But, it also makes me wonder, with that much automation, how do you ensure it's accurate? Or that it didn't miss something crucial?
That's a really valid point. And while this demo highlights the speed, Tao emphasizes the underlying system has checks and ways to verify. It's not just blindly executing.
Okay.
Another really cool demo was about interior design using IKEA.
Ah, okay. A different kind of task. How did that work?
A user just sent Manus a picture of an empty room. The request was basically, figure out the room style and find suitable furniture for it from IKEA's website.
So image analysis plus web browsing plus product matching.
Exactly. Manus looked at the image, figured out the style and layout, then it actually went to the IKEA site, browsed for items that fit, saved images of those items, and then generated a new image showing that real IKEA furniture placed realistically within the user's original room photo.
Whoa. So you could see what it would look like.
Precisely.
Huh.
And it also provided a document with direct links to buy every single one of those items on the IKEA site.
That's incredibly useful.
And get this, Tao hinted that integrating actual payment might be possible in maybe just 3 months.
So you could go from empty room photo to fully furnished, paid-for room, potentially.
That's the direction it points. It really shows Manus' potential as a general agent, as they call it. Something capable of tackling this huge variety, this long tail of different specific tasks.
Okay, I'm sold on the what it can do. But the how? How do they actually build something like this? What's the secret sauce?
Well, it seems to stem from some key insights in how they piece things together. The founders, Ter, Pig, and Red, they're all longtime coders, and they got a big spark of inspiration from a code editor called Cursor.
Cursor. Okay, what was the connection?
Their big aha moment came when they watched people who weren't coders using Cursor for everyday tasks.
Yeah.
Things like, visualizing some data or converting a video file.
Right, using code generation without really being programmers.
Exactly. And these users, they didn't care about the code itself. They just wanted the problem solved. They just hit accept, accept, accept on whatever code Cursor generated. And that led Manus to flip the idea on its head. They realized, wait, the code isn't the end goal here. It's just an intermediate step to solving the actual problem.
Ah, I see. So instead of focusing on helping people write code like Cursor,
They decided to build the opposite. Focus entirely on the result, the right panel, the solution, and run the whole thing in the cloud, making the intermediate code step basically invisible to the user.
running it all in the cloud. Why was that so important?
Several key reasons. First, safety. If it runs in the cloud, you avoid all sorts of potential problems with local permissions on the user's machine or, accidentally breaking something.
Makes sense. Keep the messy stuff off my laptop.
Right. And the second big one is what they call attention-free operation.
Attention-free.
Yeah. You can give Manus a task, find that Tokyo office, design that room, then close your laptop, put your phone away, go do something else. You just get a notification when it's done.
Okay, that is a game changer. It frees up your mental energy,
Yeah,
your attention.
completely. And they're thinking bigger, too, planning for virtual Windows and Android environments, all running in the cloud, to let the AI interact with even more types of software and platforms.
So this capability, this power, Tao broke it down into key components, right? 3 pillars.
Yeah, 3 core pillars that really make Manus work. The first one is giving each task its own dedicated virtual computer.
A whole virtual machine for one task.
Yep. And this is a huge difference compared to how you usually interact with, say, a chatbot. This isn't just a language model in isolation, it's a full-fledged virtual machine.
What's included in that?
It gets its own file system, a command line terminal, VS Code for any coding needs, and crucially, a real Chromium browser, not a headless one.
Explain that difference, real versus headless browser.
So a headless browser just processes the code of a web page without actually rendering it visually. A real browser, like the Chromium Manus uses, renders the page just like you see it. It sees the layout, the images, the interactive elements.
Ah, so it can understand websites much more like a human does.
Exactly, which is vital for complex sites. And this whole virtual environment lets Manus do really complicated things, like maybe unzipping hundreds of PDF files, pulling out unstructured data from them, and organizing it into a structured spreadsheet. Things way beyond a standard chatbot.
Okay, that's pillar 1. The dedicated virtual computer. What's number 2?
Pillar 2 is pre-prepared private databases and APIs.
Meaning?
Well, Manus is aimed at consumers, right? Most average users don't know how to write code to call an API to get, say, real-time stock data or flight information.
Right, that's technical stuff.
So Manus essentially does the prep work. It pre-configures access to useful private databases and APIs, hiding all that complexity. The user just asks for the information, and Manus knows how to get it. It just works.
Seamless integration. Got it. And the third pillar?
The third pillar is a personal logic system. This is really interesting. It basically means you can teach Manus your preferred way of doing things.
Teach it. How does that work?
Taro contrasted it with, for example, ChatGPT's deep research feature. He mentioned finding it a bit frustrating because it would ask lots of clarifying questions before starting the research.
Okay, yeah. Sometimes you just want it to get going.
Right. With Manus, you could potentially instruct it, look, next time you do research for me, I want you to confirm all the key details with me first before you execute the full search. Or maybe the opposite.
Ah, so you can customize its workflow based on your preferences.
Exactly. And Manus will remember that and integrate that personal knowledge into how it handles tasks for you in the future.
So it's not just learning from the web, it's learning directly from me, the user. That's like training your own personalized AI assistant.
It really is. It suggests that each user's Manus could become quite unique over time, tailored to their specific needs and style.
Which ties back to their core philosophy, right? Something about structure and intelligence.
Yes, exactly. Their core ideology, it's right there on their website. Less structure, more intelligence.
Less structure, more intelligence. That sounds almost backward in AI, doesn't it? You'd think more rules, more structure would make it smarter or more reliable.
It does seem counterintuitive at first glance, but get this. Even though they show off like 42 different use cases on their site, there are 0 predefined specific workflows hard-coded into the core Manus system.
0. How does it know what to do then?
That's the point.
Yeah.
They believe in having a very simple, very robust underlying structure, but leaving all the complex reasoning, the planning, the intelligence entirely up to the foundational AI model itself. First, it was Claude Sonnet 3.7. Now they use Claude 4.
So they're deliberately giving the AI less specific instruction.
Kind of. They call it less control. They avoid creating rigid systems with specialized agents, like a coding agent here and a search agent there. Instead, they give the main model more context about the task and the tools available, and then they let it figure out the best way to proceed. Let it improvise.
So the complex behaviors like that Tokyo office search, they just emerge.
That's the idea. They believe that trying to micromanage the AI with lots of predefined roles and steps actually limits its true potential. The real magic, they argue, comes from this simpler, more empowering approach. Trust the large language model's intelligence.
Okay, that leads perfectly into the next question. Why Claude? Why Anthropic's model specifically? There are lots of powerful models out there now.
Right. And Manus was very deliberate about this choice. They gave 3 main reasons. The first one is long horizon planning.
Long horizon planning, meaning its ability to handle complex, multi-step tasks.
Exactly. Remember, agentic AI isn't like a chatbot answering one question. Manus needs the AI to handle maybe 30, 40, 50 steps in a row for a complex task like that Tokyo search.
Performing an action, seeing the result, deciding the next action over and over.
Precisely. They called it this giant agentic loop, and they tested, apparently, every major model available. They found that only Claude, specifically Claude Sonnet at the time, could consistently manage that loop without messing up or stopping prematurely.
Other models just gave up too early.
Yeah, they found other models might only manage 1, 2, maybe 3 steps before incorrectly deciding the task was finished. Claude could handle the whole sequence.
Okay, that's a huge differentiator for this kind of agent work. Reason number 2.
Superior tool use and function calling.
Makes sense. An agent needs to use its tools effectively.
Absolutely. These agent products rely heavily on the AI knowing which tool to use, when, and how to format the request, the function call, correctly. Manus has, I think, 27 different abstract tools its AI can use within that virtual machine.
And Claude was better at using those tools.
Yes, but there's also a Manus innovation story here. Initially, Claude 3.5 didn't have native support for something called sync tool use, which helps coordinate complex tool interactions. So Manus developed their own technique, which they called COOT injection. It's a bit technical, but basically they had a separate planner AI figure out the reasoning before making a tool call, and then they injected that reasoning into the main AI's request. And it massively improved how well Claude used the tools. It's a method Anthropic themselves later validated, and now Claude 4 has that kind of capability built in.
So Manus pushed the envelope there. And the third reason for choosing Claude.
Alignment for agentic usage. Essentially, Anthropic has put a lot of effort into specifically training and aligning their Claude models to be good at interacting with computers and browsers, exactly what an agent like Manus needs.
They've optimized it for this kind of work.
It seems so, making it a natural fit for building robust agents.
And this commitment, it wasn't cheap, right?
Not at all. Tello mentioned they spent $1 million.
$1 million.
Each on Claude model usage in their first 14 days alone.
Wow. That really underscores the sheer amount of AI compute needed to power these kinds of autonomous agents. It's a serious investment.
Absolutely. It's not trivial.
So looking ahead, you mentioned the browser interaction. How does Manus actually see the web page to know what to do?
Right, that's key. When Manus is browsing, it sends three things to the Claude model. One, the actual text content that's visible on the screen in the browser window. Two, a screenshot image of that same visible area.
That it sees what we see.
Exactly. And three, another screenshot, but this one has bounding boxes drawn around all the clickable elements, buttons, links, input fields.
Ah, so the AI gets the text, the picture, and a map of where it can click or type.
Precisely. That combination allows the model to understand the page contextually and decide very specifically where to interact next.
Very clever. Okay, this brings up a really crucial question, though. In this field, it's moving so incredibly fast. How does a company like Manus, which is essentially building on top of foundational models like Claude, how do they stay competitive? What's their moat?
Yeah, that's the million-dollar question, or maybe billion-dollar question in AI right now. Tao's perspective is interesting. He basically argues there is no long-term sustainable moat in any specific piece of technology itself.
Because it gets outdated too quickly.
Exactly. Things change so fast. So the winning strategy, according to him, isn't about protecting one specific invention. It's about the pace of innovation and the flexibility to constantly adapt and use the best available foundational models.
So speed and agility are the moat.
That seems to be the idea. He used their deep research capability as an example. He said that feature basically just emerged naturally from their flexible, less structure framework. They didn't have a dedicated team spending months training it specifically. Whereas a bigger company, maybe like OpenAI, he suggested, might spend 6 months explicitly training a model for that one specific use case. Manus's approach, because it's more general and relies on the underlying model's intelligence, allows these capabilities to surface more organically. Their goal is to enable hundreds of these emergent use cases.
That makes sense. The flexibility itself becomes the advantage.
And underpinning all this is their firm commitment to staying cloud-only. They really believe in running everything in the cloud, prioritizing that user freedom and attention-free operation over any kind of local software installation. Even those future Windows and Android environments will be cloud-based.
Right. Keep it simple and accessible for the user.
That's the vision.
Okay, so let's try and wrap this up. Fundamentally, Manus AI is about building these effective hands for the very smart AI minds that already exist.
Yeah, it's bridging that gap.
Taking AI beyond just answering questions or generating text, and actually getting it to do complex multi-step tasks for us in the real digital world, freeing us up from that tedious work.
It really is a shift in thinking about what AI assistants can be, not just conversationalists, but actual agents of action.
It's pretty transformative when you think about the potential implications, isn't it?
Yeah.
If these advanced AI agents can really take over complex execution reliably, it frees up so much of our time and, maybe more importantly, our attention.
Absolutely. So what becomes the next frontier then? If the AI handles the hands-on execution, what does that enable for human-AI collaboration? Where do our minds focus next?
That's the provocative thought, isn't it? For you listening,
Yeah.
think about your own work, your own daily life. If you had an agent like this handling the complex, time-consuming tasks, what new things could you focus on? What new possibilities would that open up? How might your interaction with technology fundamentally change?